was really very last minute because I was initially just gonna be a hobby project. Basically what happened is I was asked to do some promotional work for Newline, and in doing so we participated in the Bring Your Own Beamer Festival from Nerdlab. So I'm gonna quickly explain what Bring Your Own Beamer is because not everybody might be already be familiar. Basically, they rent a giant building, everybody brings their own beamer and projects something, artwork, some tech demo, it could be anything. And they wanted me to basically hang up a poster for Newline. So this was the Hackerspace stand. This was basically just a poster but a bit interactive with some 3D geometry. And also another beamer, so I wanted to call people's attention. And I came up with something you can see here, up here. This is basically some data set that I found from City of Ghent. That's how it started. That I'm gonna, I'll just play the demo first maybe. Should have opened this tab ahead of time. Yeah, I think it's this one. I'm gonna let the tiles load. Basically the inspiration for this tech demo that I made, I guess, is during the Gentse Feesten, I live at the Copuur and I noticed all these drones flying over the water. And I thought it was a bit dystopian, so I wanted to like make a bit of a commentary / artwork on it. And I came up with this. I'm gonna tell more about the project later, but it was just to get people's attention, a fun project. It did well, people liked it, and yeah, that's initially all it was. But then it started to grow. First I'm going to tell you guys a little bit about the data set because I suspect to a lot of people that will be the most interesting. So it's called, let's say, the Dutch Digitaal Hoogtemodel Vlaanderen. We've got a DHMV1, 2, and it's basically just when, what year the data originates. I think the one is from like the year 2000 to 2004. The 2 is from 2013 to 2015. And that's the one we're using now. It's the most recent one they have. And right now, this year, they started shooting the third version of the data from 2026. And the person who was responsible for that was just here. So there he is. So this, you can go to a tool to download only certain areas. And maybe I'm going to show that. And I will also see the data coverage. So I'll tap out of this. Do I have it open? I hope I do. Yes. So let's have a quick look. This is Ghent, if you couldn't tell. Zoom in a bit more. Then we'll have a look at some of the data sets. There's a lot here, right? You've got these are buildings with 3D geometry. This is using basically how they made the data set. Maybe I should explain that first, is they flew a plane over all of Belgium with a LiDAR scanner. So what it measures is basically like a point cloud with a couple of data points per square meter to give an idea of the topology of the entirety of Belgium. This is the old data set. I guess when they have less, I noticed there that when they have like, how do you say platteland? The countryside, they don't do full coverage, they fly over it in like lines and they leave some places unmapped. This is the more recent one. Here everything overlaps. I think all of Belgium has measurements. Quickly look. Yeah, here you can see the distinction between the 1 and the 2. As I said, 2 is more recent. I think we should also be able to see how the plane actually flew, but maybe I'm clicking something wrong. Yeah, okay, but you've seen it on the slides. It just, there's more coverage now. They made some derivative products because the original data set is a LAS format. You've got LES and LEZ. I think the only difference is that one is raw, uncompressed, and the other is compressed but lossless. It's just a format used for point plots, but it's very taxing for the GPU. It's very difficult to do anything with it, so I would recommend the 2 data sets under that. The difference between those two is that the terrain is, they've filtered all the buildings out, and the surface is just everything together. So I think visually that would be the most interesting. But I have to preface it by saying, unfortunately, I haven't done any experiments with those data sets for all of Flanders, because it was only like a couple of weeks ago that I discovered those also existed. Yeah, this is what a raw point cloud data can look like. It's extremely detailed. I already explained the tool a little bit. Then there's another data set, another derivative, and that is they've processed all the point cloud data and basically created 3D geometries for all the buildings in Flanders, including LODs. LOD stands for level of detail. The higher you go, the more detail. So LOD 0 is just a cadastre plan. It's a 2D map, I guess, of the world. It's something you would see on OpenStreetMaps. Then you've got a basic extrusion that I think takes into account height, some basic roof geometry, and then it goes up to LOD 4. But again, I haven't been able to extract data from that just yet. And the reason is that I used a miniature data set that was just the City of Ghent, that had some more processing done to it. And yeah, so that's how I started working on this project. So the previous files, they're given in formats like raw point clouds or some, I can't think of the name exactly, but yeah, it's not important because we're not going to talk anymore about that data set. This data set, that's just the City of Ghent, is presented as DWG files, and those you open in AutoCAD, which is software for designing, for engineers, architects. So every building is one block, and it's just basically they combined the point cloud data with the cadastre planner to create an extrusion of the shape of the house, and then they added some 3D geometry to it. Initially, for those 4 tiles, it took 2 minutes per tile, but to be honest, the first time it was like an hour of fiddling around, because it's extremely challenging to work with DWG data. It's DWG only open in AutoCAD. An AutoCAD license is, I get it from my job, but it's very expensive. It could be like thousands of dollars a year. So it's very prohibitive. Yes, they released it open source with the idea that anybody can do anything with it, but if you need to spend $1,000 to open it, then is it really open source? What I tried to do is I wanted to immediately convert it to STL, because everybody here who knows 3D printers know in STL you can do anything with it. It's very easy to work with. But AutoCAD didn't let me, and the reason was that the geometry was not perfectly closed, so the buildings of the bottom of the building would just be a hole. And I said, no, I can't export this. So I'm not going to explain all of this, but basically I had to go to different loops, convert to IGS, open it in FreeCAD, which is like open source CAD software, and then I could finally get to STL. And this was, if I wanted to do all of Ghent, which was 410 tiles, I wasn't going to be able to do all of this manually. So I needed some help. I think I explained it already. I did 3 projects I'll explain, but I'll first start on the pipeline, because I think it's the most important thing if you guys want to experiment with it at home. Basically what it does is it fetches all the data from Stad Ghent, it downloads it, and then it uses ODA file converter, and this is made to basically convert DWG files to DXF, and which is the open source variant of that, and then further process it. This open source tools basically allows us to do all the hard work that we previously had to do manually. Also used, I don't know if you pronounce this, but this tool finally lets us do some calculations to get a clean STL. So that was also very handy. These are the 3 kind of demos I did to use the data. Before we go into those, I first have to explain a little bit about how the data is kind of laid out. So I think I already mentioned it, but all of Belgium, if you download the data, is a square kilometer. So you can't just get everything because it would be too much. And they do, this is the normal reaction you use, if you are navigating on Google Maps. They don't use that because then you have to take into account the curvature of the Earth. So it's a bit too challenging. So what they do instead is use a Lambert 72 projection, and that just means you warp it onto a flat plane, and then they basically have all of Belgium. They say the top left is 0 point, and then you have a y-axis going down and an x-axis going that way. And then it's very easy for a square kilometer to just give it a number and say, okay, the tile I need is number 105, 192. So then this will be the coordinates of the tile, and this will be where in the tile you're at, so the last 3 digits. So it's convenient, but it's not perfect. You have to take it into account. This is the first demo, the drones over Ghent. I've already shown you it a little bit. I'll explain sort of the behavior of the boats a little bit, of the drones, excuse me. Okay, where is it? So we'll follow one drone. Basically, oh, you guys can't see it. I just realized that. That is not good.
Go ahead.
So every time I've shared the browser, you guys have just been looking at slides. Okay, yeah. I think Johan gave a talk about how to present a talk in a way that is very accessible, so maybe I should have watched the slides a bit more. Okay, how are we gonna do this? Keep changes. Okay, now it should be better. I'm sorry, guys. Alright. So this is what I was talking about that you guys can see. Next time if that happens, just let me know. Okay, so I'll put a full screen. So this is only 4 tiles. You can't see the boundaries, but it's 4 square kilometers. I have a bunch of drones flying over here, and you can follow a single drone. You can follow the sort of the center of the swarm. But yeah, it was just meant to be a fun demo, but I do think it's a bit interesting because I studied computer science and I specialized in computer graphics. This is a computer graphics technique that is used in games to kind of simulate the behavior of schools of fish, like a flock of birds. And yeah, it's really interesting because it's some very simple rules that create emergent complex behavior. So they've only got a couple. Basically, don't bump into each other. So if they get too close, there will be a force vector pushing them apart. If they're flying near to other boats, then they will align, try to face the same direction. And lastly, they sort of there's like a center of gravity. I don't know how to explain it. They try to steer gently towards the middle of the flock. I didn't explain the name. So basically, it's a computer science researcher, Reynolds, that came up with this, and he saw they were behaving sort of like birds, but they're not birds, they call them birdoids, so boids. That's the origin of the name. Also, fun fact, Cloud Code helped with this presentation, and Cloud Code came up with all of this, these logos, which I thought was fun. Sometimes it goes a little bit too far off the rail and I have to reel them in, but this slide I think was just good. So yeah, it's nice that it's possible now. Yes, here's the next project. So immediately when I show people the first project, they were like, okay, but I want to find my house. It's not in the data set. How do I go to it? So I was like, okay, let me just do all the tiles. That's when I came up with the pipeline to get all 410 as STLs. They're just hosted in a Google Cloud Storage bucket that you guys can also use. There's no authentication or anything, so don't DDoS me, please. Maybe I should show that now, and I'm going to double check you guys can actually see it this time. Maybe I should have known that the first time. So, let's go to that demo, just like this. Okay, so let's maybe zoom out a little bit. Yeah, we don't load all tiles at the same time because it would be too computationally taxing, especially on laptops. But some info about this. Basically, how is this even possible that you can run this in the browser? Well, it's a lot of caching. Yeah, now you guys don't see the presentation. Okay, well, you guys can read my notes. It's fine. Can I fix this? No. Okay. Yeah, I won't mess with this too much. maybe gonna try one more thing. Let's do extend and present. Okay, alright. Yeah, so a lot of caching. There's various stages of caching. You've basically got a service worker which downloads styles in the background. You don't have to fetch them if you already have them. Then okay, I don't know why I did that. I'm just going to leave it now. The next stage is that they're in memory, but just loading a tile, then you've got an raw STL. You can't render that. So they do calculations to calculate the edges of the buildings that are highlighted, load them as 3D geometry. We also cache those. And then finally, it projects a 120 cone kind of that changes based on where you're looking. And the tiles that are not in the view are just also not rendered. And that again helps with performance. If you've noticed, there was like a small minimap on the bottom right. There you can see the various stages of caching. So this is available. One shade higher is they've been seen by the service worker, so they're downloaded but not loaded. Then you've got loaded but not visible. And then finally the yellowish part is the one you're actually looking at. So here I'm spinning around to kind of like show how it works. So that was the second project. Now we're going to talk about the last one. I just realized all of these ideas were actually from Hackerspace members. I said, I know something else you can do with that data set. So that's also very cool. That was in that way very collaborative. Somebody said, I think it was Joren, I tried in the past to download it, but he ran into a lot of issues. And I kind of discovered the same thing, but with Cloud Code it's a lot easier to kind of make a loop and iterate over it and kind of keep going until finally the STL is clean enough that you can print it. So I gave it a shot. This is my Bamboo A1 mini printer. It's like a tiny printer, but it worked. 5 hours later, I had my first style with the what is this? The 3000. I'm just going to say City Hills, Zimbabwe's, Balfour. That's the city class. Zimbabwe's is off the scale a little bit. Anyways. Okay, so that was another cool idea. And then again, I got some, I could phrase them as complaints, but I'm going to say suggestion from Mike that said, okay, but I'm not using the Python tool. I want to, in the browser, go to my house, select that tile only and print it. So we've had a lot of talks about OpenStreetMaps, and it is very handy for stuff like this. So this was the next phase. I'm going to zoom out. These are...
Het is niet op het scherm.
Thank you, Lisanne. So now I want to do duplicate again. Keep changes. Wow. Okay. Yeah. Full screen. Yeah. So this is OpenStreetMaps that I used. All the tiles that are highlighted in red are available. So it's from ArcelorMittal. It's just City of Ghent to Newline. It's all there. So let's maybe, anybody got any suggestions? Which area do we want to download? Maybe the hackerspace stuff? Yeah. Okay, let's do that. Psychiatry as well. And the water, yeah. How big should we pick it? Yeah, this is all done in normal JavaScript. It runs client side, so you guys can browse to it and use it as well. It's generating it. It has to fetch it out, so it takes a while. The processing is also all done in JavaScript, so it's not that fast. But it works. Okay. Well, it worked before I do a demo. That's how it goes. There we go. Okay, so let's have a look at what we got. Right, so the geometry is not that exciting because it's pretty flat. You can see here where we are, which is right here, and then the psychiatry, and then a bit of Wandelgang. So yeah, it's working. All right, so that was the next part of that project. We had a tool so people could download their house. Then I think I have a slide about a bit of the processing. I've already explained it, but a house is just basically a shell. There was no bottom, so you obviously can't print that. If you need to print something, it needs to be closed. So to do that, we had to do some processing. also you have to cut out a square tile that it doesn't match to the tiles as they are in the data set, because when you draw a square, it could overlap between 4 different tiles, so I also had to do that. I think that's basically the main part of the talk done. So I'm just going to explain a bit about this. I wanted to kind of present it in a way that I thought was visually pleasing, so what I did is, I should maybe start by turning it around so you can see the electronics. It's just an ESP32 that gets its power from USB. It has an antenna for connectivity, and it has some wires that go to LED strip, and the LED strip is, I'll rotate it a bit so you can see it. It's hidden behind the kind of the rim of the frame, and this is a frame from IKEA that was like $7. So yeah, it's just to add a little bit of an interesting presentation to it. And then I made, this is kind of work in progress, but this runs VLAD, so it's basically like a smart light bulb. If it's updating, I'm gonna have to turn it on and off. Yeah, there you go. You can do effects and all stuff. And then one thing I was also experimenting with, but it was a bit last minute, so I didn't quite finish this in time. It's an idea that I want to have use a real-time clock, check what the current time of day is, and then to kind of simulate the light around Ghent, so you can see, you know, if you want to go to a terrace, where would be the best spot. But this is kind of a work in progress. So I have kind of like a sundial that moves around.
The height of the sun is not adjustable.
Yeah, I can. You know, I would love to do that, but then, yeah, you would have to, I think, have a wall of LEDs.
More LEDs, that's always a good idea.
Yeah, more LEDs is always a good idea. But yeah, so that's kind of where I ended up. Just some experiments that I want to share because I thought they were interesting. And then the last thing I wanted to mention is Peter from OpenStreetMaps was here yesterday, and he wanted to use this data to enhance the OpenStreetMaps kind of project, where he wanted to use the 3D geometry for the roofs. I've been looking a lot at yesterday, last minute, looking at how you could do that, so I could add it to the talk. I didn't quite get there, but since the talk is being recorded, I do want to quickly mention it because I was going to send this to him. The most exciting thing so far that I've found, that would be for me the next step, is this 3D GRB, because this is all of Flanders, including up to LOD4, where you can see like even details in the roofs, like a Velux would be in there. So that sounds really exciting. So that's probably where I'm going to go next. And if it could help OpenStreetMaps, I think that would be really cool. But that's to be determined. So thank you guys for listening.